Hello everyone, and welcome back to the Fluctus Channel. At the end of its operational life, every ship embarks on one final voyage. This journey does not lead to another port or profitable cargo run, but to a shipbreaking yard, where the vessel is dismantled and reduced to raw materials. For ships that once crossed oceans and connected global trade routes, this is the last chapter of their working life. One such vessel is the G Harmony, a handy-sized cargo ship built in 2005 with a dead weight of 35,000 tons. After nearly 2 decades of service, the ship was decommissioned and sold for scrap. In early 2024, it was deliberately beached at the Kundani shipbreaking yard in Pakistan, fetching a price of $531 per ton.
मेरा नाम गुलाम मेहदी है। मैं पिछले तकरीबन 4 सालों से यहाँ पे एज ए QHSC मैनेजर के ओहदे पर फाइज हूँ। ये वर्ल्ड थर्ड लार्जेस्ट शिप ब्रेकिंग यार्ड है। पहले नंबर पे इंडिया, दूसरे नंबर पे बांग्लादेश और तीसरे नंबर पे पाकिस्तान का आता है।
The Kundani shipbreaking yard stretches nearly 10 kilometers along a tidal beach and contains 134 separate plots where vessels are dismantled. The yard uses the beaching method, a low-cost but labor-intensive approach favored through South and Southeast Asia.
और इसमें बेसिक प्रोसेस ये है कि एक शिप की एक मियाद होती है, यानी 20 साल 25 साल। उस दौरान में उसके बाद जो है ना, वो वर्किंग कंडीशन में नहीं होते, यानी वो इतना नहीं होते, बेनिफिट नहीं होते, यानी ज़्यादातर ख़राब हो जाते, पुराने हो जाते, जिसकी वजह से वो बेनिफिशियल नहीं आते कंपनी के लिए। तो ऐसी सूरत में फिर शिप को स्क्रैप के लिए दे दिए जाते हैं।
Unlike dry docking recycling, which requires expensive infrastructure, beaching relies on natural tides and manual labor. Once the ship is grounded, workers board it almost immediately. The first phase focuses on salvaging high-value components. Engines, generators, electrical systems, and navigation equipment are removed first. Non-metallic fixtures, such as furniture, insulation, wiring, and fittings, with resale value are also stripped away. Cranes assist in lifting out large quantities of smaller components, while workers dismantle pipes, valves, and machinery parts that can be sold separately. When all reusable equipment has been removed, the most dangerous stage begins. Workers start cutting through the steel hull from the top down. Using blowtorches, they slice through thick steel plates, dividing the ship into sections. These pieces can weigh between 600 and 800 tons. Gravity plays a key role in the dismantling process. Once a section is cut free, massive chunks of steel are dropped from the deck onto the beach below. Winches drag them across the sand, or front-end loaders lift them onto trucks and move them to cutting zones. There, teams of workers reduce the steel into smaller pieces using blowtorches once again.
वहाँ से छोटे छोटे पीस आते हैं, हम उनको काट के उसके फिर छपी में लगा लेते हैं। और जो हमारे साथ वर्किंग वाले और भी हैं, जो उठाकर वो छपी में डाल देते हैं। हमारा काटना है, सिर्फ काटने है।
As one cutter explains, their job is simple but relentless. Large sections arrive from the ship, are cut into strips, and then carried away by other workers. The end result of this month-long process is thousands of small steel fragments that can be easily transported to recycling facilities. The importance of recycled steel from shipbreaking cannot be overstated. In Pakistan, steel recovered from dismantled ships supplies up to 80% of the country's local steel demand. This makes shipbreaking yards like Adani not just industrial sites, but critical links in the national supply chain. Foundries clustered around Karachi depend heavily on this steady flow of material, transforming scrap steel into products that keep construction, manufacturing, and maritime industries moving. One of the most important products made from this recycled steel is the ship propeller, a component essential to Pakistan's fishing fleets, cargo vessels, and small coastal boats. The process begins with traditional sand casting, a method that has changed little over generations. Workers first prepare casting sand with carefully controlled properties. The sand must be porous enough to allow gases to escape when molten metal is poured. If gas becomes trapped, it can create internal voids that weaken the final casting. A metal propeller pattern is pressed into the sand to form the lower mold cavity, known as the drag. Workers compact the sand using their body weight, wooden tools, and metal rods, shaping the mold entirely by hand. Once the drag is complete, a metal cage is placed on top to form the upper mold half, called the cope. Sand is packed into this section as well, supported by wooden sticks, and compacted with metal rods. After shaping, the cope is carefully lifted and separated. A graphite-based release agent is sprayed onto the mold surfaces to prevent the molten metal from sticking. Both halves are then preheated with blowtorches to remove moisture and burn away organic materials that could produce gas during casting. The most physically demanding stage follows. Scrap steel is loaded into a furnace and heated until molten.
मेन जो काम रह जाता है ना, मुश्किल जो हार्ड काम है वो है माल डालना। ये भट्टी है, इस भट्टी में माल गलाते हैं, उसके बाद इसको हैंडल उठा के फिर इसमें हम माल कल्टी करते हैं, डालते हैं। तो सबसे जो मुश्किल इसमें काम है, हार्ड काम है, वो है माल डालना पंगे के अंदर।
After cooling, the mold is broken apart, revealing a newly cast propeller. Final machining then begins. Excess material is ground away, the hub is drilled on a lathe, and the surface is polished. Finally, the propeller shaft is fitted through the hub, completing the component. From ocean-going cargo ship to recycled steel and newly cast machinery, the journey does not end at Gadani. Instead, it continues supporting industries, livelihoods, and maritime activity long after the ship itself has vanished from the sea. For more than 425 years, one family has shaped sound itself. In Innsbruck, Austria, the Grassmeyer Bell foundry has preserved the art of bell making across 14 generations. Today, brothers Peter and Johannes Grassmeyer carry forward a tradition that began in the 16th century, crafting bells that now ring in more than 100 countries around the world.
Unsere Glocken läuten Jahrhunderte. Die älteste Glocke, die heute noch Leute, die meine Vorfahren gegossen haben, ist aus 1637.
Creating a Grassmeyer bell is a meticulous process that blends centuries-old craftsmanship with modern precision. Each bell begins with a hand-built mold made from an unusual mixture of clay, bricks, calf hair, hemp, barley chaff, and even horse manure.
Besteht aus Lehm. Die Glockenform, die schabloniert wird, wird aus Lehm, Ziegel und dann sind aber ganz viele noch Bestandteile, die hineinkommen, wie Kälberhaare, Hanf, Gerstenhäcksel, also Pferdemist. Ganz viel kommt hinein, um diesen Lehm zu verfeinern, dass er luftdurchlässig, aber nicht metalldurchlässig ist, dass er ein schöner Guss wird.
This carefully balanced material allows air to escape while keeping molten metal securely contained during casting. Religious figures and words that will adorn the exterior of the bell are also added to this mold. Artists melt bright red wax to pour into the detailed carvings of these images. The mold is then filled with a glowing alloy of 80% copper and 20% tin, a combination known as bell bronze, prized for both strength and acoustic quality. As the metal heats to extreme temperatures, it turns a deep red color, signaling the precise moment required for a successful cast. Once poured, the bell must cool slowly. This process alone takes at least 2 full days, allowing the structure to solidify evenly and prevent internal stress. Only after cooling can the bell begin its transformation from raw casting into a musical instrument. The Grassmeyer family aims to create what they describe as the Stradivari of bells, instruments that are visually striking and musically flawless. Unlike many bells that are simply cast and hung, Grassmeyer bells undergo an extensive tuning process. Craftsmen gradually grind the bell wall to exact thickness, shaping its sound with extreme precision. Digital sound analysis is then used to confirm accuracy. This level of precision allows their bells to perform not only in church towers, but also in symphony orchestras across the globe. Beyond creating new bells, the Grassmeyer team is also trusted with restoring historic ones. Cracked bells lose their resonance, sounding dull and lifeless. Through specialized techniques, the foundry can restore tone and clarity, even in world-famous artifacts. Now, as the 15th generation begins learning the craft, the bells of Grassmeyer are set to continue chiming through history for centuries to come. From the dismantling beaches of Pakistan to precision foundries and centuries-old bell workshops in Europe, this story shows how metal never truly reaches an end. Ships, steel, and craft are continuously reborn through human skill and labor. Whether recycled into propellers or transformed into bells that ring for generations, these materials carry history forward, proving that even at the end of one journey, a far longer legacy can begin. That's the end of this video. I hope you enjoyed it. Make sure to subscribe to this channel so you don't miss any of our new content. See you next time.